so I don't feel like messing with a lot of Google Meet. Now, what I'm about to show you is a draft. All right. On Thursday, we have an incredibly important day. On Thursday, we're going to start the tutorial days for the RWR project. But we're going to have a fairly straightforward project. I cannot tell you enough, this is not 380/30, 411, or 285. It's not the same thing when I say class project. So I want you to be here with me instead of pushing ahead, all right? It's a little different than that way, okay? We're about exposing technologies and maybe connecting some dots, all right? So anyway, you're gonna have 2 or 3 weeks to get this done. It's way too much time for this much of a phase, but you're gonna have homework assignments the same time that you have this project. So it's not gonna be exclusively what you're working on in this class. 415, the RWR project, that is a 3-phase project, is going to be the development of a simple quiz web app that's built using now one of the things that's going to be changing is this, right now it says the mean stack, which is Mongo, Express, Angular, and I know that I don't say that word right. It's a speech impediment issue. I can't say it right, all right? And then Node.js. So the project is a very simple 2-page Angular or Vue app that uses a REST API built with Node.js, Express, MongoDB. Now this is going to be singular. I thought about doing it in pairs, but I don't want it to be where we have it to where people pair off with people that have been exposed to this. So I think it's going to be individual for every single person. And the other thing is I'm going to release all of the phases before the first phase is even due. And you can't just do the whole thing and turn it in one shot. You have to kind of snapshot it and send in the individual phases, because the whole point is to do it the right way, or as best as we can, the right way. So you have to turn in each one individually. So what is phase 1 about? Well, phase 1 is the creation of a web service. And I use these words a little bit loosely. But we're going to create a web service that uses Node.js. Now, Node.js is JavaScript, but it's a server-side framework for handling the logic. It's where all of your actual code is. Most of what you're going to do, as far as getting the quiz to work and all this stuff, is going to be in Node.js. It's what handles a lot of your database connectivity, your translation, all that stuff. It's going to be in Node.js. It's going to use Express. Now, Express is one of those things, like, you're not even going to know that you're using Express. Like, it's endpoint routing, that kind of stuff. You can kind of think of it as your server, right? But as part of the stack, it routes the endpoints that we're going to create. And then MongoDB, which is a document-driven database, where it's kind of funny. Like, we're going to be dealing with JSON objects. It just stores every record as a JSON object. Is one way that you can view it, okay? That's not really what happens, but you might think of it conceptually that way. This phase includes setting up the project and deploying it on the Heroku cloud application platform. Now, I really wanted to switch to the Google Cloud platform this year, but one of the things is so I've got certifications in Azure, GCP, AWS, and with each one, I realized that there's benefits and pitfalls to each one of those architectures, and part of 415 is picking the right solution to the right problem. And the more I tried to get GCP to work with what we needed done here, the more I realized that Heroku is still the best solution for this project. The reason why is because Heroku is going to be, I'm going to set up an account there. I'm going to get an address to, and every time I do a git commit, it's going to deploy my application for me, which is exactly what you're going to have all this stuff like analytics and logging and monitoring, all of this stuff on Heroku, what they call dynos or something like that, that it would take maybe a day or two just to get it working well with something like AWS, because in AWS it would like span multiple services. So anyway, we're going to use Heroku. I'd rather use something that's more relevant to large scale, but I don't think it's good to use a bad solution just because I want to show you how to use it. It kind of defeats the purpose of this class, which is making the best decisions. So anyway, in this phase, your app should be able to create simple multiple choice, little caveat on multiple choice, quizzes to be stored in MongoDB, allow submission to existing quizzes to be stored in MongoDB. Quizzes contain title, description, set of questions that are 1, true, false, 2, multiple choice and single select, 3, multiple choice and multi-select, 4, short answer. This phase is going to offer 4 endpoints, and we'll make sure that we understand what endpoints are. An endpoint that takes in a GET request to a quizzes. And this is an endpoint to get a summary of all the quizzes that are currently stored in the MongoDB, or the MongoDB instances. An endpoint quiz ID that takes in GET requests that gets a summary of a single quiz with submissions. This request string is going to have a little bit of data to it, enough to do the query. Post request at a endpoint new that is an endpoint to create a new quiz, and a post request endpoint quiz ID where you submit a single quiz result. That's what you'll be submitting. Does it say the word Angular anywhere in there? Not a front end. It's not. You're going to use JSON where it's needed. In other words, every request and result is going to be JSON. Now, a couple of people here are thinking, wow, this is really easy. It's awesome. It's good. But where we're going to come from, listen. Oh, yeah, so the single quiz submission maybe. Like some values to enter in that's like, this is a quiz submission or whatever. So one set of answers that have been filled. So, yeah. And it seems pretty loose there, right? Pretty loose in how it's going to be submitted. So, but like if I took a quiz, I would submit my results to quiz/ID. Yeah, it's kind of weird. So it's totally weird. All right. So the input in our request body is going to be JSON. The result is going to be JSON. We're going to be testing these endpoints using something like Postman. It doesn't matter what you use. Something like Postman, all right, to do our endpoint testing. There is no front end for this. The value of this is we're going to take a very simple application. There's no user authentication. There's no any of that stuff. We're going to take a fairly simple application. We're going to be focusing a couple of different things, like setting up an environment for deployment, where we do things like code pipelining to make sure that we have a quality pipeline from where we write our code to where we deploy it to where we test it. That's what we're focusing on. All the code part, I'll get you most of the way there in the tutorial section. On Thursday, we're going to come in, and I'm going to sit at that table right there with my back to it. And it's kind of funny because in the tutorial section, I'm not going to teach you how to do it. You're going to teach me. Right? I'm going to play the part of somebody that doesn't know what I'm going to struggle. I'm going to do this, and we're going to get through it together. We're going to use what's called active coding to instill active learning for us to get through this important point. Right? It is, I believe, important for you to be here. And if you're going to be remote, you're going to miss out a little bit on the, because I'm not going to be Google Meet. Like, it'll be on Google Meet, but I'm not going to be paying attention to it. I got to pay attention to the crowd that's going to help me through it. if you're going to be at Google Meet, it ain't the day to just kind of leave it open and do something in the background, because there's probably 7 or 8 steps to getting this done, and we're going to do the first 3 or 4 in class. All right, so it's just not one that you want to miss. It's just not one that you want to miss. And I do understand this might be a little bit on the easy side for people that have worked in the mean stack or Mevin stack before, but just try to be present with it and see some stuff. And remember, iron sharpens iron. Everything's going to be open about this, so it'll help us just kind of get through this process together. I will post this phase just before class on Thursday, and from that point on, you'll be able to turn it in. I'll have them all posted before spring break. That way, if anybody wants to go home on spring break, get one AWS or I need to give you all the sheets for that. One AWS and one something else, UiPath, either or, and get an A on the final. You may just be done with the class by spring break. You may just have earned an A already. So we'll talk about that more in the future. But so I'll have it all up. And the only thing is if you do it all in spring break, you have to turn in the 3 phases separately. You have to snapshot where you were to make sure that we get there. Anybody here know Jeremiah Weaver? Good, awesome. So he's the guy that's helping me out on this. He's the one that's going to be pushing Vue. He's actually going to come in and teach some of the front end stuff. Last year, before that was last fall, he came to every section of 161 that I taught and would do near peer teaching, and he's really, really good. So I reached out to him. He was interested in showing the Vue part. And to be honest, I don't know Vue. It's a little bit more bleeding edge than cutting edge, I guess. So I think it's still fairly new. So I'm looking forward to learning too. I'm not going to look at it before he teaches it because I love the way he teaches. So anyway, we're working on it together to develop this project. He's really awesome. He works at CGB. He was the information technology distinguished graduate last year. So it's very good. Any questions about this? A couple of, go ahead. Correct. Awesome. Yeah, and I know that for some people that have worked in mean stack, you're probably the benefit's going to be seeing the different learning a new cloud platform. That might be it. Maybe how we create test suites in Postman if you've never done it before. Isolation of the API, isolation of the data source layer, anything we can do. If you go to that link on the GitHub page, that's like from 2 years ago. I'm going to update that as we work on Thursday. So there's something there now, but it's a different project. So it's completely useless for what we're doing. But it'll be updated during the tutorial on Thursday. Awesome. And that's the whole point of this, is just to make sure that we have a very controlled project, very concise, scoped project where we introduce you to as many relevant technologies as we can. But giving 3 weeks to do this seems insane. You're actually going to have another programming assignment like this week, right? So the other homework assignments don't stop. This is on top of that. So I want to make sure you have plenty of time to work it into your own schedule for when that's going to be due. I don't think it's because of time. I think there are programming assignments that are harder than this, especially after the tutorial. Some of you will probably finish it during the tutorial because I'll be going too slow, right? So anyway, let me see if there are any questions in me. Nope. It's worth 20% of your final grade. It's worth going to. We are very close to some people being genuinely looking at this and seeing whether or not they can be done with the class. The midterm exam, everybody got their grades back. In this class, out of 22 people in this class, I want to say 5 got 100 or more. And the one person that we had a 104 was from this class as well. The median grade was above a 90. The average was lower, but if you were one of the people that got, below a 70, I mean, when I gave the exam review, I had the exam open in another window, right? And I was just reading the questions from the exam in a very off way, just to kind of limit how much you had to study. So, just remember that lesson when we do the final exam review about exactly what it's going to look like. The test-driven development homework was, it was a simplified version of that on the exam. So just be aware of that next time. I think it's definitely the exam was fair. I think it was rigorous enough. I feel like a lot of people felt challenged by it. But I also feel like it was fair since so many people did so well. And there's just a lot of really students that have been here and connected to the class. So I'm very happy that 2/3 of the class walked away with an A. I am happy because I don't feel like it was an overly easy test. I think it was a fair test. Any questions about the exam? So we are going to do our lecture today as well. And the lecture that we have, this one's dense. This one's deep. This one goes low level, right? I love talking about it, but it is dense. It's codey. It is code oriented. And it goes back to like this very foundational thing about code, where the observation I'm going to make before the end of the class, it's one of those things that if you learn one thing from 415, I hope that you are aware of this one thing. It's a light bulb moment, I hope, for some people that they can really bring in and make them better developers. That's what we're hoping to get really into. But we have to take a step back and remember where we've been, because it's been like 2 weeks since we had normal lecture. We had really cold weather. We had Mardi Gras break, no Mardi Gras, and we have to remember where we were. We were talking about design. And design patterns are these commonly occurring problems in computer science. You see over and over and over and ways to solve. The easiest one for me to capture, and for me the one that was my aha moment, was the singleton pattern. And the problem that it had was that it was always coming up that we needed one instance of something. We just needed one. So in the past, we talk about C++. In the past, C++ is known for allowing global variables to give you the power to do whatever the hell you want to do, and most of the time that ends up with you hanging yourself, right? But they're known for these like easy outs of global variables. So they're kind of known. But the singleton pattern says that, hey, I know a solution to this. And it's going to be neat. What we're going to do is we're going to take that constructor, we're going to make it private. And we're going to make this static entity called instance that allows us to go out and it will handle all the instantiations and all that. It's going to solve all of our problems. And it's neat. It's novel. It's interesting. Your next homework assignment is to create an application that uses a singleton design pattern. But is that the only way to solve that problem? Is it a good way to solve the problem? There you go. That's it. And it's generic enough that you can apply it to a lot of things, but it's like this one really good way of doing things. Does anybody else remember one of the other design patterns we talked about? Factory, absolutely. Factory. Another one that's novel. It said, okay, we've got this idea of polymorphism. Superclasses, subclasses, and we exploit polymorphism all the time by running through arrays of a superclass. And then we can exploit the inheritance whenever we use it. That's polymorphism. This one says, hey, let's use polymorphism the other way. Let's take the superclass and create objects in subclass. And it's neat. Is it the only way to do it? It didn't even exist up until about 10 years ago. Man, it hurts saying 10 years ago since I was there. Hell, it was 14 years ago. All right, didn't exist until 14 years ago. All right. So there are other ways to do it. This was just a novel way. It's a neat way. The last one we talked about was strategy. And strategy was that like you can have these two completely different types that are defined by just a little bit. Like for a tank, it was like your coordinates and the direction you're facing. That's it. That's all it really is. So if you had the tank behaving completely different in different scenarios, you could just destroy one object and recreate it. There's like that many variables here. And then you have them vary by their type, aggressive behavior, defensive behavior. Once again, not the only way to solve it, but a possible solution, like the framework of what it would be to solve that problem. Today, we have one that's a lot denser, but in an odd way is a lot more relevant. Because this one, although you don't really deal with it that much, has a lot of practical applications to code, specifically the domain layer side of code. And we're going to talk about how to handle some really big core logic of these applications. For a lot of this stuff, look, it's about how it applies to business. BI, business intelligence, or business rules, or business processes, right? And inside of business, there's this very common problem. Common problem with revenue recognition. Now, my brother used to do this all the time. He was a lawyer, politician. When he was a lawyer, it was like you don't get paid in the month of December or January as a lawyer. You don't. You make no money. You make all your money in the other months. Because people just don't pay for lawyers. February is a great month because you get paid like to the city of Franklinton will pay him like $8,000 to be the town's attorney for the next 12 months. But the problem is he gets paid for that in February. And he has to live on it until December. And so there's this problem that we have about when you get paid those big amounts, how do you split out that income in a way that makes sense for the business so that we can make better decisions on it, right? Y'all might know this from a different one. You might get like a scholarship refund and like a loan payment at the beginning of the semester, and you got to live off of 3 months instead of 1. Yeah? Okay, there you go. When I was in grad school for 7 years, and I get my student loan payment, my fellowship payment, and I was rich. Oh my goodness, I would get like $14,000, right, on the first day of a semester. It was awesome. And I got a wife and a house that has to live off of that for 3 months. Less rich, right? So I had a simple solution. I never knew it was in my banking account, ever. I had a spreadsheet, and it was like January, February, March. And at the top, I just had, if I had $12,000 for those 3 months, I put $4,000 at the top, and that's how much I had for the month. Basic budgeting, right? Now, it's easy for us when we're talking about that level, right? It's harder when we talk about companies because there's more than just one source of income, right? We do need to know how much. We do need to spread out income across multiple months. And here's the worst part. Do you think the tax man cares whether or not you're going to use that money in December even though you're paid in February? Nope. Taxman gets paid by quarterly taxes. So it's completely different. It's just a completely different part. All of a sudden, the finances of a company start getting really, really hard to deal with. An example they use. Suppose you got paid $12,000 a year to consult for a company. Really, really good practice to go ahead and assume that you're making $1,000 a month. Really, really good. For personal and for companies. So let's consider a practical application. Now, I don't like this example. It is the example the textbook uses. So I do like it for one reason, that it's a little bit more conceptual. Like you can conceptualize this better. All right. Let's consider a company that sells 3 different types of products: word processors, spreadsheets, and databases. Now, what they want to do is they want to consider each one of these sales split. For word processors, let's just recognize all of it on the day of the sale. So if somebody pays $100 for Microsoft Word, we just take the $100, we'll put it in the bank account, sale of $100. But for Word, for spreadsheets like Microsoft Excel, we're going to take a third of that, and we're going to recognize it on day one. We're going to take the other third and do it after 60 days, and another third after 90 days. Same thing for databases. 1/3 when we sell it, 1/3 30 days, and then 1/3 60 days. Why would you treat something like Microsoft Word and Excel different? Let me ask you this: which one's more likely to make tech support calls? There you go. See, a lot of people go, yeah, I saw that, right? Everybody knows how to use Microsoft Word. There's going to be no support there. They know how to build a resume, they know how to use templates. But Excel, if something goes wrong, there's a likely support call. Databases, something goes wrong. Maybe something changes and they need to make sure that they're really getting involved in their migration to the new database. There might be a cost there. So from a company perspective, they might want to split this out so that they can better adjust for things like support costs. Kind of makes sense? I know it's a stretch, but I appreciate you for being there with me, all right? So let's think about this. And I'm an object-oriented nut. I'm just all in on the system. And I struggle with a lot of modern programming because sometimes it's not as object-oriented as it should be. I get mad, like PHP scripting can get lazy quick, right? Love PHP. Hell, there are things that I do that are real programs that I know I can do quicker in PHP. So I use that stuff all the time. Yeah, you finally have, yeah. So I mean, I get the value, but I'm all in object-oriented. Everything I do is object-oriented. So my first approach to thinking about this is, what objects do I need to develop this? How am I going to implement this? I want to create, when I sell a word processor, I want to put I've made $100 today. But when I sell a spreadsheet, I want to make $33 today, $33 60 days from now, and $34 90 days from now. I want to think about what is that solution to this problem. How can I make this work in code? And I do want you to think about it for a second. Somebody here is probably thinking of a word processor class, spreadsheet class, that's all good. Probably a sale or a contract class for whatever it's sold in. But the general idea is that we're going to create a 3-class processor where we have a contract that is what we have sold, is a binary association between the product that we sold or processor spreadsheet, and a binary association with the many for the number of revenue recognitions we have for this. The revenue recognition is itself a class. So let's look at the first. The first solution that we have for this is the one that the vast majority of you would do. I'll be honest with you, if I gave you this as a programming assignment, 90% of you, 9 out of 10 of you would find your way to this design pattern. This design pattern, one thing, by the way, previous slide, class diagram, told y'all we're going to use this stuff. Class diagram, we're going to use the hell out of it. All right. So this is the basic idea of how we're going to solve it. Just use the database to solve it. If we want to find out for a contract, we can find out how many recognitions have done by date. That's asset like. So if we want to say, as of today, how much money have we made from this contract? All it does is it runs a query. It says, select the amount of revenue that's been recognized so far from our table, where the contract ID is this, and it's been recognized on the date that it should be recognized on is less than the date that we feed, like today. And then it returns, as a result, a single amount, select an amount from this. I'm sorry, it'll say the set. This is upset. Let's look at the next slide. So, if we want to see how much revenue that we have for a contract in a date, all we do is we find the recognition and we add up the amounts that were returned for it. Let's see what it looks like when we put it in the other way. We make a sale. And when we make the sale, what we do is we calculate our revenue recognitions for that sale. All of this stuff, we're just getting the information about the sale. Right here, for the type, is the type of word processing. All we do is we take a single recognition to our database. We insert a recognition for the contract ID that we have, and we're calculating for, with the total amount of revenue that was what we sold that word processor for, and today's date, for the date of the sale. But it differs for things like databases, spreadsheets. Sorry, this is database. For spreadsheets, we insert a recognition for that contract with 1/3 of the amount of revenue for this date, 1/3 at the date plus 60 days, and 1/3 at the date plus 90 days. That's all we did. So whenever we want to know how much money that we have recognized as income at this date, we don't go to our sales database. We go to our recognitions database. And we see how much money of our sales has been recognized at this point. All we did is we saw the problem right here in this line of code. When we make a sale, we create something called a recognition of the sale. We split it into 3 records in the database. And we just do a little bit of logic to calculate the database. Does see what's going on there? I told you it was a little bit. We use the database to solve. We want to take a sale of a spreadsheet, and we want to split it into 3 different sales. We're not going to call them sales, we're going to call them revenues. And we're going to do 1/3 of that sale today, 1/3 in 60 days, 1/3 in 90 days. If I were to say this another way, we just pushed off all of the thinking to the database. Right? So that's how we solve the problem. Here's the thing, if I'd actually explained this lengthily and asked you to solve this problem, 9 out of 10 of you would probably use the database to solve it. There's some big pluses to this. It's very procedural. We're all comfortable with databases like this. And in fact, it works well with SQL databases. It works really, really well for an intuitive result, an intuitive implementation. The only problem is it's okay to talk about when there's only 3 revenue recognitions. Sometimes they can get a little bit more complicated. This won't work if I'm developing code for AT&T because the domain logic is all pushed into the structure of the table. Sometimes the complex logic will overdo what you can just hide inside the SQL table. And the last one, I can't really describe why it's the case. So we have this problem of revenue recognitions. And the transaction script design pattern says, hey, let's take care of it with the database. Cool. Transaction script says, hey, if you want to split sales across multiple months, enter it into the database with multiple records. That's the design pattern. As is with design patterns, is this the only solution? Absolutely not. In fact, there's another design pattern that is exactly associated with this problem, and that is inside of the domain model, we're going to create a different solution. So here, I'm going to try to talk less. I'm going to try to, and that's hard for me. I'm a talker. Let's look at this. There's a couple of changes here in this class. The trash can looking thing is a database. I don't know if I said this in class. You all know what it looks like that? A database looks like that in UML? So, old school hard drives, those platters, and really back in the older days, you had a huge drive, it would be stacks and stacks of patterns. So that really was like the old platter. That'd be a big storage, whatever. So yeah, that's what it looks like. There's some differences here. First off, the relationship between contract and product, it's not binary, it's unary or unary. I like the word unary, but I'm country. I don't know if it's right. The relationship between product and a new class that is abstract called recognition strategy is an unary association. And then we're going to have some subclasses with that abstract class recognition strategy called complete recognition strategy. When I told y'all I was an object-oriented person, like if it were up to me, which it's not, I would teach object-first programming at Southeastern. You learn what an object is before you learn what a variable is in object-first programming. Now, that sounds crazy, but a lot of places teach it. Stanford teaches it. This is going to be an object-oriented solution to this. We're going to use inheritance and classes and objects to solve this problem. I'm going to try to talk less. It's so hard for me to talk less. Look at this class. Class of revenue recognition. Has two member variables, amount and date. How is it constructed? There's a method that is recognized by, and it returns true if the date is after or currently today. That's a revenue recognition. Sounds a lot like the record in the database that had the date to it. This is just where the query, this is a method instead of a query. We now have a class called contract. This is the sale. So we have a contract class. So one sale like this, me selling that word processor to Kevin, it's a contract object, right? It has member variables. Oh, have to talk to us. Take a second and read this. So many important observations. The first couple of member variables, there's only one that I really care about, and that's this one. The second line, oh shoot, I forgot, I can't do that. The second line right here says private money revenue. This is the total amount of money made by this sale. But the last member variable is an array list called recognitions. So you've got both there, right? You made a sale, you create that as a contract. And there's two things that are related to it. First, how much did I make? And then second, where do I recognize these dollars that I made? The recognitions are stored for an object or a class, whatever we would look at this way, as an array list of all these recognitions. So if I want to, for that contract, get how much money I made on it, how much the sale was, I would do contract Kevin's sale dot revenue to get the total amount of money that I was paid. But if I wanted to know how much have I earned of that, how much of that revenue have I recognized by today, I would do Kevin's sale dot recognize revenue today. Right? And then this function would go through, and for each revenue recognition card in our recognitions list, if it is recognizable by today, add to our result the amount that's there. That's a reminder that is recognizable by, object-oriented everywhere. It was part of that recognition. Two amounts, the revenue and what's been recognized. It split off the recognized portion into an array list of recognitions. And the last slide related to this. Down here. Oh, all right, I'm sorry. I got confused here. For each product is a superclass with subclasses. They are word processing, spreadsheet, and data. This uses a design pattern. Notice the design pattern here? Returns a product for a new word processor, and it's going to pull in this string the name of the product, and it's going to create a new product with the name, and inside of it, it's also going to construct something, a new complete recognition strategy. The complete recognition strategy, in that case, is a class that recognizes the entire thing at one time. For a spreadsheet, with the name of it, we create the product with that name in a three-way recognition service. And it creates an object for this, and it has two parameters in it, 60 and 90. So today, 60 days from now, and 90 days from now. This is what those look like. For the three-way recognition strategy, it's a class. It's in recognition strategy. And whenever we calculate revenue recognition, what we do is give it some contract, we add a recognition, we create that object, and we add to it the revenue divided by 3 at the time that it was signed. We create a new recognition for 1/3 the total revenue for when it was signed, plus the first offset, which in this case is 30. Then we create a new recognition, new revenue recognition for 1/3 plus the second offset. I talked way too much. I knew it was freaking going to do that. We use classes and objects to solve this problem. We create a new contract. As part of it, we calculate the recognitions. For the product, we have a different revenue recognition strategy that's created. It's objects, that's all it is. So in this case, we relied on object-oriented programming. The first one, we had transaction script. And it said, hey, push all that stuff to the database. Push all of it to the database. We'll have a database table called recognitions, and we'll just put a new record for every time we want to recognize it. And I said the name. This one said, no. We're not going to use the database. We're going to use the domain model. And inside the domain model, we're going to calculate for every object when we want to recognize the revenue one. We're going to do so with a class called recognitions and a array list that holds all of these recognitions. The different strategies for how we're going to store those in a different class that has lots and lots of different subclasses and all that stuff. We're going to do that there. And what that's going to do is it's going to give more power to the code. We're not going to rely on the database. The database is just going to have the sale. Our code is going to do the logic. There's some really good stuff about this. We can handle more complex logic this way. Because if we don't, it's easy enough for 30, 60, 90. But what about when we start getting really weird and we have 1,000 products and we want to do it in code the right way? Well, then we can create subclasses all day long. And I love how we join programming. Subclasses are awesome. It's a way to solve it, right? It makes sense. So the complex domain logic is really great. It's easy to modify. It's easy to test. It's all in the code. And that makes it easier because guess what? We don't have legacy data in the database that we have to go fix later. If we want to change up how we do this, we don't have to. But the problem is which one was easier to implement? Transaction script by a ton. If I were to guess right now how many of you just understood all of the code that I showed, I would be shocked if half the class understood the code completely. It was dense. It's tough. Because of that, I don't think it's always the best solution.
You know what I really liked about this, Dr. Burst? Was the, where was it where you had the 3 functions where we're dividing by 3? I just forget what slide it was.
Yeah, I know exactly where we're at. We're in calculate recognition. So right here.
Yeah. Something I really liked is the fact that now we can actually test these individually as like one unit of work for this whole, or for each function.
Absolutely.
So now we can, if somebody comes in here and maybe they change a number, right, where we're using like dividing by 3 or something, we can actually test it before it actually just gets sent off to the database or before it even leaves this function.
Absolutely. And that principle is test isolation, right? So when he says move it into a single unit, what I believe he's saying, if I were to kind of describe it back, is we're able to isolate the logic so we can test that specific revenue recognition without it being stored in the database and backtracking from the output, right? We can really test this because it isolates that logic that much better. Is that right, Scott?
Yeah, exactly.
Awesome. I mean, 100%. Like, you totally get it. Mm-hmm. So now we get to this point where we've had 2 design patterns. One talks about pushing the information into rows of a database. And another where it talks about, no, we're going to have object-oriented programming and we're going to consider these objects. The second one relies on object-oriented programming inheritance. The first one relies on SQL queries. And there's a very important thing, and this is the thing. Give me a second. I got to rework. This is the most important thing from today's lecture, all right? And I know the people at home won't be able to see perfectly. I'm going to do my best, though, okay? All right, you may need to pin the video of at home, and somebody tell me if I need to move the thing. it comes down to this. What is the difference between a row and a table, a record and database, and an object? What's the difference? It's one of those conceptual things that I need you to have. If you've never thought about it, I want you to have a light bulb moment on this.
The value it holds.
This is one of the most important. That's absolutely. So let's think about what the object is. Right? What is an object? Well, an object is an instance of a class, but a class, by people, is a blueprint. Let's consider the student. One of the standard classes that we describe. And classes have two things that define it. The first is the state, and the second is the behavior. The state that we're talking about here is we have different member variables. Like we can have a string value for the name. We can have an integer value for the W number. And for other stuff, we might have some member methods like enroll. Or we might have another one for like print schedule, right? That'll be our member method. But let's think about what happens when we create. That's a class. That's not a grade. That's not a grade, right? Classes are these blueprints for how we define something that we would show or store as a They're a description, right? A blueprint. When we create an object, when we create a grade, well, I'm not going to use grade. I'm going to use John. Student John equals new student. And inside of it, I'm going to have my name, my W number. Let's pretend that we can leave with a 0 there. And when I run that line in code where it says new student, this is what happens. Inside of the stack, it gives me a variable of type student. And it uses whatever variable name, which I use John there. But what gets stored here is nothing more than a reference. A reference to heap. The heap is an unorganized set of data, and inside of it, it gives me a series of memory or block of memory that is exactly the same as what the member variables in this class are. So it gives me a string variable called name, and into it, it puts my name as a string. It gives me an integer variable. And in there, puts my W number as an integer. An object, does an object have behavior? That's a trick question. Does an object have behavior? This over here is the class. Do classes have behavior? That's where we define it. But this is a trick question. Because the answer you know from 280 is yes, objects have behavior. Does it? Does it? Does it? Right? We're talking about real stuff now, right? No, it's two variables. That's what an object is. It's two variables with the values filled in. This is an object. An object is those variables filled in. Let's think about what a table is. Now, I'm not real good at teaching databases. It's not my favorite course to teach. I taught it before. I think I've taught somebody in this class before. I think it's called a schema, right? Where we have like the table name. And the table name we have is like student. In each one of these tables, we have like, I think they call them attributes. And the attributes will be something like name, and they'll have a type. And it'll be like, I think it's called like short text or something like that. I don't know. Bar chart. Bar chart. We'll do bar chart 256. There we go. Bar chart 256. Something like that, right? And then we have ID number, no, I call it W number. And this will be like a long, right? And if I wanted to put myself into this database, I would just put John Burris, it's a string, 0518049, assuming once again that we can do leading zeros. That's it. There's now a row, or a record, or an entry, whatever the hell you can call it, for John Burris in this table. Do databases have behavior? Only what you can accomplish in a query. This thing does not have behavior. You might be able to do a little bit of stuff with like the relational attributes and auto increment checking, but very, very basic stuff. There's no member methods here. No member methods. But you know what this looks a lot like to me? This is a lot like an object. In a way, you can view objects as rows in a table. You really can. The record, John Burris, is of type student. This table, student, defines the member variables that it takes for you to be a student, but it doesn't contain behavior, right? The only way that we can get the behavior is to take it out of the database, select that record, and put it into memory in an object of a type class, and then we can do behavior on it. This is an important observation to make. What's the difference between storing it here and storing it there? There is an answer here. There is a difference between there and there. What is it? What is it? Yes. And there's an important aspect to that. Justin said one's not in memory. This one's in memory. This one isn't until we select from it. Yes, that's the other piece. Those two pieces together. This is memory, this is on permanent storage. Therefore, this is persistent and this is volatile. Right? That's the other thing that's important to note about it. When we have this question today about where do we recognize revenue, I'll be honest, I don't give a dang about where we recognize revenue at. What I wanted you to pull from that is where do we make the logic? Where do we do the calculation? Because at the end of the day, we have these pieces of information that are stored in memory that are objects. There is a strong relationship between the objects we use in memory in the database where we store them persistent. There's a huge relationship there. And as we move forward, that's what we're going to work on, is we're going to look at how we can maintain the relationship between a record in a database and the object that's in storage. Woo! It was hanging on that much. I cannot believe I didn't just disconnect everything. All right. Questions about this? Have you consciously thought about this before? Yeah. Good, awesome. It's very important. Very, very important that we understand the relationship between these two things. And with that is the inherent limitation of this. I can't do domain logic here. The closest thing I can do is like the transactions. See, the transactions, we did have some logic there, but it was limited to like the structure of the table, right? Like we just split it out so that the data told us what the logic was. In order for us to do logic, we have to move it out of the database and over to objects and memories. Then we can use our domain model. Then we can do some calculations. Then we can do some thinking. It's a very important observation to make. The way that we did it today is we showed how we do that using the database to split out that logic, and another one where we use the code to handle that logic. The next step that we're going to do is we're going to talk about something called the active record design pattern, which helps us remember this. So that every time we make a change on an object in memory, we make sure that it gets reflected in the database. Because we have some very serious concerns there when we move forward. Are there any questions? All right. More than anything else today, that last little bit is what I need you to know. That there's a relationship between, I mean, that's probably going to be on the final exam. Like, describe the relationship between records in a database. No questions? All right, well, that's where I'm going to end. I know we're about 10 minutes early. But on Thursday, we are going to be having a tutorial day. It is worth coming to. If you feel ultra comfortable with this stuff, and you can probably get it out in a day or two, I'm not going to be offended if you sit in the back and kind of half pay attention. I won't be. The only thing that will offend me is if after we set this up, somebody asks me, I'm working on a project, but I don't know how to do my commit into Heroku because it's going to be part of the tutorial and it's going to be part of the video that I post, and like that's going to be that'll be the part that annoys me. Okay, so it's worth coming out to check out. We are going to be going very slow. By all means, you should be, while I'm doing this, you should be doing it on your computer so that you're kind of already set up to do it. I'll see y'all on Thursday.
Hey, Dr. Burris, is there anything that we should like have going into it so we have less like configure time?
That's a good question. I think I do it all in the browser, but it may be worth installing Node locally for.
Yeah, it sounds like a good idea.
Probably installing Git. I'll send in, thank you for bringing that up, Scott. I'll do my run through my practice session, and I'll send out an email with the links to what people need to install.
Yeah, that way we just speed up that process for sure.
Absolutely. That's a good idea. Thank you, Scott.
No problem.
So your laptop's not working today?